Good morning, dear students. Now, I'm going to discuss one more problem on your fan, a little bit different from previous problem what we solved. Different means concept is same, only one parameter I'm neglecting, I'm using one more parameter, that's it. See, the problem is like this, find the temperature distribution in a one-dimensional fan with the physical properties given in below figure. There is a uniform heat generation, or there is a uniform generation of heat inside the wall, that is Q is equals to, or Q bar equals to 400 watt per meter cube. Now what is given? 4 bar watt per meter cube. That is Q bar is given, or Q or Q bar. Sometimes you use it as a Q, or sometimes you use it as a Q bar. Heat generation means you can use it as a Q bar. Unit is watt per meter cube. Now this is what the problem given. 80 degrees Celsius temperature is given at this wall. Okay, K equals to 300 watt per meter degree Celsius. Then insulation. See, is told that insulated. The insulated means there is no any heat flux. Heat flux will be equal to 0. Generally heat flux will be equal to 0. Radius is given, that is 0.001 meter. 0.01 meter. Then dimension, that is length is given, that is 0.08 meter. Now, how to solve this problem? See, it is almost similar to your previous problem. He has not given any condition like take it into two elements, all those things. Because of that constant cross section, to simplify our problem, what I have taken? I have taken it as a single element only. Single element only. That means how many single elements, how many requirement here? We require only two nodes. Now locate on node 1 here, node 1 here, node 2 here, formulate a finite element model. See, I have written all the dimensions or data given here. First, I will go with the FE model. First, I will written what is the T1, what is T2, then length of the element is 0.08 meter, K value is given. Okay. Now, procedure is same. First, go for your step 1, that is conductivity matrix. See, only one element is there. K itself, we call it as a K, because only one element is there. Whatever Ke we are going to get, that itself as a K. That is K equals to K, A into K divided by LE, 1 minus 1 minus 1, 1. We know what is the area, pi d square by 4, because it is circular, pi d square by 4 into 300, that is your K value, divided by 0.08, 1 minus 1 minus 1, 1. This is what. Then you can finish what is the K matrix you are going to get. Now, what is next step? Convection. Previous problem you have solved for a convection. Now, if you observe here, convection is not given, that is H will be equal to 0. Directly convection matrix is 0. Then what is the force vector? Force vector without capital F will be equal to 1 is heat generation matrix minus heat plus matrix plus your convection. See, convection is not given, because of this Fh will be equal to 0. Then there is no heat flux because of insulation, heat flux is also 0. Only thing F will be equal to FQE. F Q bar E, that is element. See, this is also nothing but F, because only one element. Whatever you are going to get for this, that will be equal to F. What is the formula for that? A Q bar LE by 2. See, previously we are using a convection problem. Now here there is no convection, but your heat generation is given. How to determine when your heat generation is given? A into Q bar LE by 2. A into Q bar LE by 2. 1, 1. Now if you so go for here, area, pi d square 4, Q bar given is 400, length is given, everything you calculate, you are going to get this. 5 into 5.0 into 10 power minus 3, 5.0 into 10 power minus 3. Now what is the next step? See, now you got K, H is 0, everything is 0. What is next? Your equation. What is governing equation? K into T, H into T is equals to F. Now convection is directly I am making 0. Then my matrix will be 1.8 minus 1.8, because K no, T1, T2, this one. Now what is given? See, next one is boundary condition of solution. T given is T1 equals to 80 degrees Celsius. Substitute in any of the equation. If you take your first equation only, second equation only, minus 1.8 into T1, because first column you eliminate, because already know. Because of this, now because this element is there, minus 1.8 into T1, see, plus 1.8 into T2 equals to 5.0 into 10 power minus 3. If you can calculate it, you are going to get 80.002 degrees Celsius. That means because here steady state problem, whatever the heat entering is the same amount of heat will be there at the end also, because of steady state problem. If there is an unsteady state, the temperature will vary with respect to the time. Because of this, you are getting same value of temperature. Now this is one type of problem. See, I can solve one more type of problem. That is one more means when rectangular fin is given. See, this is all our circular fins. Okay. Now when rectangular fin is given, so problem is same type of problem. Determine the temperature distribution of a rectangular fin as shown in figure. Assume steady state heat transfer and only one conduction process. Take heat generation inside the fin is Faraday. See, previous problem, what type problem now I had explained, same problem. Only thing is a rectangular fin. When rectangular fin is given, what is your difference? Area. Area you should take it. What is area? Your this is width into breadth into width. Okay, B into H you should calculate 0.04 into 0.02. That is what I done it. Then if you observe your problem, entire procedure will be same. Entire procedure will be same. Same two elements, only 1 and 2, 0.06 meter. Then K, same K, LE by 1 minus 1. K is itself is equals to K. Okay, you are going to get K value. This is a value. Then H convection is not given. H equals to 0. Then how to calculate your I here? I think R is written is nothing but your FQ bar. That's it. FQ bar E. FQ bar E. Directly I done it. FQ bar E equals to Q bar L into AE divided by 2. A Q bar, you know what is the value given, 500, you can calculate everything. You are going to get, say FQ is equals to 0, FH is also 0, then F equals to FQ bar. Directly K2 into this equation, same for the procedure you can follow, you are going to get a value that is 423, 422.9. Generally for these fin problems, because of steady state, what are the temperature entering the system, same temperature you are going to get at the second end also, if you are taking it as a single element. If you take it as a 3 elements also, same temperature you are going to get. 2 elements also you are going to get same temperature. This is what a problem on fins. Thank you.